transition, that is Romax. Romax the ring, that is, Romax the ring, sa inyong 2001, that is, 5 up, balance. Or that is what? So, 0.5, 0.5. 0.5, X prime, prime, 600, beta 1.
Beta 1 yan. Over
600, FY, F1 plus
600.
600. The ring, above the ring, so that is Romax, 25, FC prime, beta 1 over FY, times 3 over 50. Ano ang kami ito lang? So, saan ito pag-determine? Using what? If your rho Rockwell ratio is less than Romax, then that is singly reinforced. Otherwise, there is more than duplicity. Then, if your MU, so meaning the MU actual load, is less than the MU max, meaning the resisting moment, then that is singly reinforced. So, this one, I'm talking about the capacity of the because in RC and the design, you only have two types of problem. Design problem and investigation problem. So this one is design problem, this one is investigation problem. You need to get the MU, given sizes or reinforcement. Like, while this one, given MU, you need to get the size, dimension, or reinforcement. Okay? So, after I discuss ang principle ni singular reinforce. Para magkasagot kung asa nagikan. So, suppose you have this AS, B, and the distance between the reinforcement centroid to the compression fiber. That is the compression fiber, this is the tension fiber. So, this one is. So, this is now the section of the key. But if I want to draw this, you have this, assume this is a neutral axis. So if you want to draw the stress of the beam, the stress distribution. So this one is, what is this one? The depth of the compression. That's this standard, 25, X prime. This is A, the depth of the compression block, and it has this force, and that force is D. Force to balance, it is resisted by force C. Compressive force of concrete, tensile force of steel. So we know that the concrete, the core concrete is weak in tension, stronger in compression. Likewise, the steel, weak siya compression, strong siya tension. That's why they are both one part symbiotic. So they are negative. So that's why we have called this beam or reinforcement, the rebars as reinforcement. So the reinforcement. Ingon si steel nga, ingon si RC nga, ako na kayo nag-tension, so I need reinforcement. So that's why it is the pavilion. Because we know that yung forte ni steel is only tensile. Weak lang sa compression. Si RC, weak sa tension, but strong sa compression. That's why, ito may mga compression members, RC, yung column, yung PVC. In steel design, wala kita pinista niya ang steel. That is, RC, yun sa reinforced concrete. Footings. Okay, footings niya ang full steel. Hindi lang, this is reinforced concrete. That's why we know that the factory, RC or concrete is stronger in compression. Okay? For this one, the forces are separated by what distance? This one. This one is, since this is what? This is D.
Yes.
And by static, this is what? Rectangular section. Centroid is A over 2. So therefore, this one is
D minus A over 2.
Applying for statics, we have that C is equal to D. And we have, sa formula ni,
0.85 FC prime EB.
This one?
A is F1.
F1.
F1. FS.
lang sa pag-FY. Na, tulad mo sa mga FY ka. Kung FY ka, umihil. Saan na umihil?
Bigay.
Saan na umihil?
Bigay.
Saan umihil? Saan na umihil? Kung saan ang hil? Isa yung hil. Of course, still. Saan ang hil? Saan ang hil? Saya. Saan ang hil? Hil. Yielding point. Bigay. Bigay. Meaning, ibuhos niya talang niya gusto.
Oh.
Ano yan? Isa na yan. So that's why we don't need to have this FY. We'll investigate it that it will yield na. Posible po, dili siya mong yield, meaning, hindi nga si RC nga, kaya lang ko sa inyong strength sa tension. Kamay lang, balance compression. Reserve ng one strength mo, ina-under ang flow. Meaning, what is siya fully na exert or nakatag ng force sa steel. Kung natag na talaga ang puso, meaning, FY na siya. So that's why we have this formula. 25 FC prime AB equal to ES. This is not the general formula for our relationship between the compressive strength of concrete and the tensile strength of steel. Okay, makita ang FY niya. So, anin ta dito sa strain diagram. Strain diagram. So according to DCP, the maximum strain is obtained by the concrete is what? 0.003. This is the concrete side. And the tension side, this is ES. Strain in steel or tensile strain. So, kung saan mo sa distance? C. Therefore, this distance is what? D minus C. Strain, recall your mechanics. Ito mo makukuha. AS, what is strain? What is strain? Deformation over? Where is P over? E. And what is this one? Stress. Stress over E. You have to relate the result C. So this one is strain of steel is equal to what is your stress of steel? Fs. That is Fs and that is E of steel. 200,000. So after you pull it, so Fs over 200,000. So you have this relationship of triangles. So this one, you get the tangents. What you have this? Point 0.03 over C is equal to Fs over 200,000 all over D minus C. With that, we have another formula for Fs in determining the Fs. So this is D minus C over C. Memorize this one. So those are strains, stress, and the section of the beam. So how do we determine if that steel will yield or not? Balik ka tayo. Check it. Let's check. So first is you have to assume. So assuming, or assume steel yields. If you assume steel yields, then you set Fs is equal to
Fy.
Kung kailan department, huwag kala yung basis ay mong strength. You set Fs equal to Fy. Because Fy, mura mo na iya, iya, specs mo sa imo, o yan stress sa imong steel. Wala iya. So you said the maximum is Fy. Fx maximum. Therefore, from the formula, it becomes now 25 S prime AB AS Fy. Then you can solve for A, you can solve for C, and you can solve for S. So once you have Fs is more than or equal to Fy, meaning steel yields as correct assumption. You set Fs is equal to Fy. We'll use Fs is equal to Fy. Otherwise, if your Fs is less than Fy, meaning steel not yield wrong assumption, you solve for Fx. So if this is the case, meaning you will not need this one. You need to solve under A, under C, and under Fx by using this formula, the general formula. With that, we have 0.85 So if fs is less than fy, then you can use the formula. When you define fc prime, what is a?
Delta
Delta
1
1
C.
c times b is equal to as 600 b minus c over. You can solve for c, you can solve for a, and you can solve for. But based on this one, based on this one, since we are what? We equate this c is equal to meaning here in one, but different direction. What will happen? It creates one or moment. So there is moment produced by this different direction of equal forces, equal magnetic forces. So this couple or moment that is equal to, and that moment is same as couple C D minus A over 2. Or you can have D minus A over 2. Ano lang ha? So if you want to get the nominal mo or the ultimate strength, take note of the keyword. Ultimate strength, the design strength, maximum strength, or that is what? VMS. Equal to review, or that is D minus A over 2, or D minus A over 2. Alam, formula ha? So these are the basic principles easily reinforced familiarity. So any question? So, siya kung saan gamitin ng ring A, we know that this one is what? 0.5 F prime AB. This one is AS FS. Ha? So meaning, kung na ka rin, ano yung gamitin rin mga value? So if you have this done, ano yung gamitin ng FS? That's why I let this as FS. Because in the long run, you have this Fs equal to Fy or Fs the new value. So if it belongs to this case, so meaning whatever the A yung nasolve ba doon may gamitin rin. And si A na rin. Pero I prefer to use this one. Ano naman? A yung nakabatayan. Wherein kung I use this one, si Fs kung si A ang pwede na ito i-input. But if you put Fs, wala kung A, wrong na. But if you want to get the nominal or science, okay? So any question? So not all the time I will ask for require the maximum stress, maximum moment. For example, what is the for the beam there is a prompt beam, blah blah blah. What is the W value for the intensity of the load considering you have this beam reinforcement. For RC, tama na rin. The rest, if you want to get the example na, ang given sa being loading na, ang ipangita, what is this value? So that is that RC. What is one? You just equate this one to max. You just get the maximum moment for the speed in terms of W, then get the Of course, if you're designing the beam, you get the what? Maximum moment for that beam. As basis for your design. Like if you design the beam, naka-full restrained beam dia. Sama niya yung moment dia, full restrained beam. Diba? Yung moment dia, ano eh? Sama siya, dikati, W, L square of L. May mo ano po? Well, W, L square of L, 4. Negative W L square of L. What is maximum moment? Ada siya. Ada siya. Dapat ibaw ka sa maximum moment. Ada sa inyong theory. What is the impact for this one? Usually the maximum moment is at the fixed support. Kasi ako sa fixed support. Otherwise, there is a special loading here. Okay, so Dinalakan mo dito ang mga buwan, so that is not part of the RC. That is part of mechanics, part theory. That's why we have this, we have cell reinforcement ratio. Rho. Real problem, what is a rho? Now, what is the reinforcement? What is the beam coefficient of resistance? RF. In coefficient of resistance, RF. Nah, dapat dibawakan, what is RF? Children, what is dibawakan apa lah? So this is the procedure or steps. How do we decide or get that ES? After that, if you want to get what is the number of bars, just divide it by the number of bars. Okay, so that's yeah. If you need the number of bars for 20 mm bar, ES over the area of bar. Anyway, we have examples for that. Then, for design or investigation problem, what are you want? Investigation, assume still yields, you set FY, you get A and C. After that, stress check. In check C, FS. If your FS is more than or equal to FY, meaning for assumption, still yields, proceed to step number 4, wherein you use FS equal to FY. Klaro na kaya? So if your FS is more less than FY, not yield, from assumption, use the FS value computed in step number 3. Kaya nga step niya. Step number 3, solve for the new FS. Pero kanin siya, if your FS more than FY, dito sa step number 3, dito sa step number 4. Right? Diba? Getting the reduction factor. Because reduction factors are dependent on the value of your FS. Sir, ang mga lagay sa strain na ito. Strain na itong gamit. That is 0.005. If you're more than 0.005, then 0.9. Diba? What is 0.005? In megapascal. That is 1,000. That is 1,000. Diba? Strain, what is strain? Ang uban tinggali, nagamit ng strain in getting the value of V. Ano sa punod sa bomba? So if you get, if you want strain that is equal to 0.05, more than is what? If your AS is more than 0.005, this is what? This is required. Huh? Required na to. Multiply na mo, this is equal to FS is more than 1,000. Di ba kita? So importante si asa man magamit ni V? Asa magamit? Sa design strength. If ever the problem requires only for nominal strength, then we do not use the V. We do need that to solve the V. Dito na tao. And then you have that formula. Again, as you know, you have a color ni Kalkuit,